Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 4.6, Model Direct Variation. Okay, so we're skipping a warm-up today. So two variables x and y show direct variation provided y equals a times x, and a is not equal to 0. So the non-zero number a is called the constant of variation, but if you look at this equation, it's really just the slope. Okay, but there's something special about this equation. Notice we're not adding on anything to the end. So the y-intercept for all of these is always going to be 0. So that's what this part is. In other words, the y-intercept is always 0. When this happens, we say that y and x vary directly. Okay, so y and x vary directly. Okay, so if we can write it so as y equals a number times x, then it's a direct variation. And that's all it is. Okay, so the equation y equal to 5x is an example of direct variation, and the constant of variation is 5. So this is what our a is equal to. Okay, but the equation y equals x plus 5 is not direct variation because the slope or the constant of variation would be 1, but we have something on the end. We don't have a y-intercept of 0. Okay, and you can think about this in real life. Direct variation is best modeled with money. So for working, if you work 0 hours, you get $0. This is our hours, and this is our money. Okay, and then for every hour you work, you're going to get some amount of money. And we're going to get a direct variation equation that looks like this. Okay, all right, so it'll go through 0. Tell whether these equations represent direct variation. If so, identify the constant of variation. So the only way really to tell is to go ahead and solve for y, right? Y as a function of x. So in this one, I subtract 5x to both sides. 0 minus 5x just makes negative 5x. I divide by 4 and I get negative 5/4 x. So this answer is yes, it is a direct variation. And the constant of variation is the slope, which is negative 5/4. Okay. In part B, I'm going to subtract x to both sides. So I get negative x plus 5. Okay, and then flip all the signs because I'm dividing by negative 1. So that becomes positive x, and this becomes subtract 5. And this is definitely not direct variation. And I don't have to tell the constant of variation because it wasn't direct variation. Okay. All right, so graph direct variations equations. Notice what's the y-intercept every time. This should be 0. If it's not, then it wasn't direct variation. Okay. So remember, if I wrote this as y equals mx plus b, it would have a 0 here. So we put a point at 0 on the y-axis, and then the constant of variation, or the slope, is 2/5. So that's up 2 and over 5 from this spot. 2, 3, 4, 5. And then we could find a new point. And we could keep doing the same thing, up 2 and over 5, or go backwards, down 2 and back 5, and down 2 and back 5. Okay. When we're done, we get this line. And we could write y equals 2/5 x on it. Okay, so that's our direct variation. All right. In this one, same thing. The y-intercept 0. All direct variations will have a y-intercept of 0. And then the constant of variation is negative 2, which means our slope is also negative 2, or negative 2 over 1. So that's down 2 and right 1. Down 2 and right 1. Down 2, right 1. Down 2, right 1. Okay? Dun, 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 dun. And there's our equation. Y equals negative 2x. Okay? All right, that concludes our first page. Okay, on page 2, our first question says, the graph of a direct variation is shown. So we can tell that this is a direct variation graph because the y-intercept is 0 and it makes a straight line. Okay, so write the direct variation equation. So we know it's going to be in the form of y equals the constant of variation times x. Remember, the constant of variation is just our slope. So to go from our y-intercept to our one single point that's plotted here is up 4 and right 2. So up 4 and right 2 is 4 divided by 2, which makes 2. So our constant of variation is 2. Okay, so we get that by doing the slope of this line, which is 4 divided by 2 for 2. And then it says find the value of y when x is 12. So we just take our equation, y equals 2x. We replace x with 12, and then we work it out. 2 times 12 is 24. So here's the value of y. Okay. The graph of the direct variation equation passes through the point 3,5. Write the direct variation equation and find the value of y when x is 9. All right, so this says, well, we only have 1 point. How are we going to find the slope? Well, that's really easy. We also know another point every single time. It's 0, 0. So our slope is 5 minus 0 over 3 minus 0, which is 5/3. Notice it's also just the y coordinate divided by the x coordinate. And that works for all direct variation equations. If you just take any point on the line and you divide the y by the x, you get the slope. And remember, the slope is our constant of variation, a. So I'll write my equation, y equals ax, and then I'm going to replace a with 5/3. Okay? And then we need to find the value of x when y when x is 9. So here's our first answer. And our second answer, we take our equation, we put 9 in for x, and then we just work that out. So 45 divided by 3 makes 15. So here's our second thing. When x is 9, y is 15. Okay? An object that weighs 100 pounds on Earth would weigh just 6 pounds on Pluto. Assume that the weight P on Pluto varies directly with the weight E on Earth. Write a direct variation that relates P and E. Okay? So assume that the weight P on Pluto varies directly with E on Earth. So we want P Pluto weight, and we want it to be equal to some Earth weight. Okay? And an object that weighs 100 pounds on Earth would weigh just 6 pounds on Pluto. Okay? So our equation here is going to be the output number, which is 6, divided by the input number, which is 100. Because we have our input number of 100 here, 100 pounds on Earth, makes a Pluto weight of 6. And since it's direct variation, we also know 0, 0. So we could do 6 minus 0 over 100 minus 0. And notice, once again, it didn't really matter. We didn't have to do that work because we could have just taken our point and put the output coordinate divided by the input coordinate to get the direct variation constant. Okay? So our slope is going to be 6 over 100, or the constant of variation is 6 over 100. Okay, that's part A. All right, what would a boulder weighing 750 pounds on Earth weigh on Pluto? So now we know the Earth weight, and we'd like to know the Pluto weight. So this is where a calculator might come in handy. So I'm going to grab mine, and we're going to do 6 divided by 100, and then times that by 750. So on Pluto, this boulder would only weigh 45 pounds. So the Pluto weight is 45 pounds. Okay, remember, sentence answer, or sentence question gets a sentence answer. Okay. Okay, on our last page, we start off with a little piece here about ratios, okay, and direct variation. So the direct variation equation y equals ax can be rewritten as this ratio y over x equals a. So basically, they solve for a in this. So the x's would cancel out. For all x that are not equal to 0, because of course we cannot divide by 0. So in the direct variation, the ratio y to x is constant for all non-zero data pairs. So let's make a table for direct variation of some data pairs. So we know for direct variation it's going to go through 0, 0, and it's going to make a straight line. So these should go up evenly each time. So we'll go up maybe by 5s over here. Okay. All right, and what it's saying is for every xy, if we divide the y by x, we should get the same number. And by the way, that number is going to be our constant of variation. So for instance, if I take 5 and 1, this order pair 1, 5, if I divide the y by the x, I get 5, or the output by the input. And the ordered pair 2, 10, if I divide the output by the input, I get 5. And the ordered pair 315. If I divide the output by the input, I get 5. And that's why for direct variation, instead of calling this guy the slope, they call it the constant of variation, because no matter what ordered pair we pick other than 0, 0, if we divide them, we keep getting the same number. Okay. All right, so at number 6, the table shows the cost C of downloading S songs at an internet music site. Explain why C varies directly with S. Well, it's very easy to show why they vary directly. If we just take every output and divide it by the input, we can show direct variation because all of them divided keep making the same number over and over again. So 693 divided by 7 makes 99 cents. All right, so explain why C varies directly with X. All SC data pairs when divided make 99 cents. Okay? So in other words, if I take a C and divide it by S, I get 99 cents. Okay? And I showed that work here. All right? So write a direct variation equation for S and C. So my cost is going to be equal to my constant of variation. Well, I just did that. Here's my constant of variation. It's always 99 cents times the number of songs. All right? And then our last problem here, in example 6, suppose the website instead charges $1.99 for the first 5 songs you download and 99 cents for each song thereafter. Why is this not a direct variation? So let's do this. Songs and our cost. And the place where it's going to be a trouble is going to be between the 5th and 6th song. So for the 5th song, it would be 5 times 199. So if we buy 5 songs, we have to pay $9.95. But when we buy that 6th song, we pay a different price for that. We only pay 99 cents for the next one. So for here, we're only going to pay $10.94. Okay? So let's take these two. If we divide cost by songs here, and we do $9.95 divided by 5, we get $1.99. But as soon as I do $10.94, the next cost song pair, divided by 6, I no longer get $1.99. $10.94 divided by 6 is going to give me about $1.82. Okay, which is different. So it is not reasonable to model this with direct variation. Because not all costs divided by song pairs are equal. Okay? If I was to graph this, it would start off looking exactly like a constant of variation. So this is our songs and this is our cost. It would have a 0, 0, 0 songs, and it would go up until I hit data point 5, and then it would go up slower. So since it's not a straight line, then we know it's not direct variation. Okay? All right, this concludes this section, and it also concludes our chapter 4. So next time we will review this section, and then you'll have a test review, and we'll have a test on the day after. Okay? So I will see you in class.